All right, so now let's look at a different type of function. Okay, you'll notice that this one is different because in addition to just your x, there's also an x squared. Now, if you had to guess, what type of function would you say? Well, most people would say either quadratic or linear or maybe some strange combination, but the fact is it can't be both, right? Yes, there's a linear piece, there's a quadratic piece, but remember, linear has to be straight. It has to have a constant slope. That's its special feature. A quadratic is U-shaped. It can't be U-shaped and have a constant slope. That's not possible. So we have to figure out which of those is the heavier, more important one. This is why in our first unit we learned about degrees and order of monomials and polynomials. The overall order of the polynomial tells you what type of function it is. So if we look at this, we say, well, my first term has an order of 2, a degree of 2. My second term has a degree of 1, and my last term has a degree of 0. So therefore, the polynomial has the same degree as the highest degree monomial, which is 2. So this is a second degree polynomial, which means that that is the most important piece. Therefore, by looking at this, we should then be able to guess that this is going to end up as a quadratic formula. But, you know, what the heck? Let's figure it out. Let's see if that actually is the case. Okay? So what we're going to do is we're going to just start putting in some numbers and see what happens. So let's go with negative 2. We'll put that in. So I'll go 2 times negative 2 squared plus 4 times negative 2 minus 6. So negative 2 squared, we do exponents first, right? PEMDAS, always PEMDAS. So 2 times 4 plus 4 times negative 2 minus 6. Then we do the multiplication. So 2 times 4 there is 8. And 4 times negative 2 would be negative 8. And then minus 6, 8 times 8 is 0. Minus 6 is negative 6. So I get a negative 6 there. So I go negative 2, negative 6. So I go ahead and put that point down. There's 1 point. Okay, let's go on to negative 1. So I go 2 times negative 1 squared plus 4 times negative 1 minus 6. So that would be 2 times positive 1, still exponent first, plus 4 times negative 1 minus 6. So 2 times 1 is 2. 4 times negative 1 is negative 4. And then minus 6. 2 minus 4 is negative 2. Minus 6 is negative 8. And it's okay if you can't do it that fast. That's not a problem. So I put negative 8. So at negative 1, oh, it went down there. Okay, which is fine. It went down a little bit. Okay, so now let's put in 0. I don't know what's going on. So let's put in 0, and we'll go 2 times 0 squared plus 4 times 0 minus 6. So 0 squared, of course, is 0 times 2 is 0 plus 0 minus 6. And so it goes back to negative 6. Now, you should already be able to tell, if we've decided that this is quadratic already, you should be able to tell kind of what the graph should look like, right? Because we see here, we've got a point up here and a point down and then a point up. So somewhere it changes from going down to going up. And that point where it changes, remember, is called the vertex. Okay? And so you should be able to tell that, yeah, it's some kind of quadratic here. All right? So I could go in and I could put 1 and 2 in. But remember, I really only need 5 points. And this is obviously the center of the graph here. So if I get 1 more point on this side and 1 more point on the left-hand side, then I'll have the 5 central points. And hopefully that'll be enough to kind of finish off and give me all the information that I need. Okay, so rather than doing positive 1 and positive 2, I note that the graph has been shifted over a little bit, so I am going to do positive 1, but then I'm also going to do negative 1, negative 2, negative 3. So I'm going to put in negative 3 there. Okay, and it's okay that these are out of order. I'm doing it as I go. Okay, so I'm going to go ahead and work those out. You don't need to see that again. Okay, so you'll note over here on the right-hand side, I did put in 1, and I worked it out and got 0, and I put in negative 3, and I got 0, and so I should now have a nice quadratic curve. I have 5 points, the center of my quadratic graph, and so I go ahead and draw in my line. Okay, now with that information, I've now graphed the parent function, non-parent function. Let's see if we can now figure out the answers to the questions. Now shape, of course, is easy. It's just a U shape. Domain. Remember domain, I want to list all the x values. Now because of the line, that means there's an infinite number of x values there. So I'm going to watch. It says it's going up and to the right. So it's going to the right forever because of the arrow. And then it's going to the left. It's going to the left forever. Remember, these arrows demonstrate the fact that I know that I only put in 5 of the possible points. The points could keep going on and on forever. And it will go on to the left forever. So if it goes to the right forever and to the left forever, then we can simply just say that x is all real numbers. Now for the range, note that it does go up forever, but it doesn't go down forever. It only goes down here to -8. And -8 is the lowest that it gets. Okay, now if -8 is the lowest that it gets, there's a couple of ways to write this. If you want to say that it goes down to -8 and up to positive infinity, then you can just say that y is in between those. Note that y can be -8. That's an actual value. We got that. So I need the equal sign under the inequality. For the infinity, though, I don't need it because it can't actually be equal to infinity. Now, you don't really need all of that because all we really need is the fact that y is greater than or equal to -8 or -8 is less than or equal to y. And so that's actually what I'm going to put in my box here is y is greater than or equal to -8. Note that because I put the y on the left-hand side, the sign had to switch around as well. Okay, I can get my x-intercepts. I see 2 of them, 1, 2, 3, at -3, 0. And at 1, 0, I write them as points because that's what they are. Note that a quadratic doesn't actually have to have x-intercepts, right? You could vary. Can you think of a situation where a quadratic would not have an x-intercept? Hopefully you thought of something like this, like if your quadratic is up here, right? Or if it's flipped upside down and it's down here. You know, situations like that, it might not actually cross the x-axis. It will cross the y-axis because eventually those lines are going to cross the y-axis no matter what. So you're always going to have a y-intercept, but you might not have an x-intercept, and that's okay. The y-intercept, of course, we can see right here. The y-intercept is at -6. So we go 0, -6 because the x value is 0 and the y value is down at -6. And now we have the name of the parent function, which we determined before was quadratic. The equation of the parent function, of course, is y equals x squared. That's before anything was done. Note that the only things happening to x here is that it's being multiplied, added, and subtracted. That's why it's still a quadratic, because it's just arithmetic functions there. And the special features, there's 2 of them for a quadratic. Do you remember what they are? The first one, of course, is the vertex. Okay, which we can name. The vertex is that point, the very bottom point, or if it's upside down, the very top point. It's where it stops going down and starts going up, or the opposite. So we see here that that's at -1, -8. All right. Now the other special feature of a quadratic is that it has a line of symmetry. Okay, the line of symmetry goes right through the middle of the graph. And I want to talk about this for just a second. So it goes right down the middle, splits it. Okay, and it always goes through the vertex. Axis of symmetry will always go through the vertex. Now, to be able to write the axis of symmetry, the axis of symmetry is a line, and so we have to be able to demonstrate the fact that it's a line. Now, you'll notice that this line goes through x is -1, and it also goes through the vertex for which the x value is -1. And so really, anywhere where x is -1, that line goes through it. So the way that we're going to write the axis of symmetry is x equals -1. Now what's so neat about the axis of symmetry is you'll notice that these 2 points are both 1 space away, right? That's 1 space away to the right, that's 1 space away to the left, and they both have the same y value, right? They both had -6. This point right here is 2 spaces away. That one is also 2 spaces away from the axis of symmetry, and you'll note that they both have the same y value. This is going to be a very important pattern to us later on because it's going to mean that we only have to do half as much work, because if you do everything on the right hand side, you can just reflect it over then because of the symmetry. All right? That's pretty much it for quadratics. We've answered all the questions. We've talked about the special features. I think you're ready for another one.